This is the video on ions. So remember, in each of these videos, there are two codes. One, it will be a written code on the screen. The other will be a verbal code said by myself. Each code will be 3 numbers. You will need all the codes in order to move on with that homework assignment. So on these slides, look what is written in green. That is something that you can use to write in your notebook and make a bulleted list to get the ideas behind this big topic. So this is the weekly review video code. I would recommend this, the written code. I would recommend writing this down somewhere. So let's take a look at the Bohr model. So Bohr models are pictures that show all the electrons in the orbitals of the atom. So the first orbital has 2 electrons, has a spots for 2 electrons. The second orbital has spots for 8 electrons, and the third orbital has spots for 8 electrons. So you can see off to the right, the picture, there is a Bohr model. It's got 11 protons, 12 neutrons. You can see in that first orbital, it has not valence electrons. It has 2 spots for electrons. In the next orbital, it has spots for 8. In the next orbital, it does have spots for 8, but this one, because it's a sodium atom, it only has 1 valence electrons, but there are spots for 7 more. So let's take a look at valence electrons. So valence electrons are electrons in the outermost orbital or ring of an atom. Now, are they more important than the rest? The answer is yes. They're the ones that are doing most of the movement during a chemical reaction. Bohr models also show valence electrons. So up until now, we've looked at Bohr models, and you've looked at if we look at this carbon atom, you can just count the valence electrons, and it has 1, 2, 3, 4 valence electrons in that outermost ring, in the outermost orbital. But if we're looking at the periodic table down here, here's how you can find valence electrons by looking at the periodic table. The first step is to find the element on the periodic table. The second step is to find the group number on the top of that column. And then for groups 13 through 18, just ignore the 1. So if you look at the group number 1 has 1 valence electron. Group number 2 has 2 valence electrons. We skip over the transition metals. Group 13 has 3 valence electrons, all the way up to group 18, which has 8 valence electrons. Remember, group 13 through 18, just ignore the 1, and that'll tell you the number of valence electrons. So let's get some practice. So find the number of valence electrons for the following elements. Lithium. So if we find lithium on the periodic table, it has 1 valence electron because it is in group number 1. Phosphorus. That if we look at that, it is in group 15 and it has 5 valence electrons. Iodine is in group 17, which means it has 7 valence electrons. Remember, for groups 13 through 18, ignore the 1. Argon is in group 18. It has 8 valence electrons. Calcium is in group 2, meaning it has 2 valence electrons. Oxygen is in group 6, which means it has 6 valence electrons. So really easy to do, really easy just by looking at the periodic table. As long as you can find the element and know the group number, you'll be able to find the number of valence electrons that element is going to have, that atom is going to have. So that brings us to our big question for today is, why do atoms gain or lose electrons? And you can look at that little comic. It says, I've lost an electron. And then the other atom says, are you positive? Because if you lose an electron, you're losing that negative charge and you're becoming positive. So it's just a little atom joke there. So let's take a look at ions. Ion is an atom that has gained or lost electrons. It is an element that has a charge. It is either positive or negative. Now, why do atoms gain or lose electrons? And that has to do with the octet rule. Most atoms want to be surrounded by 8 valence electrons or 0 valence electrons. It's all or nothing. They either want a full valence shell or get rid of that shell altogether, whichever is easier. So for atoms with less than 4 valence electrons, those atoms are going to lose electrons to form positive cations. So a cation is a positive ion. So if we look at this, we look at sodium. Sodium has 1 valence electron. So what it's going to do is, it's easier for it to get rid of 1 valence electron to get down to 0 than it would be for it to gain 7 electrons to get up to 8. So it's going to lose that negative charge and become a positive cation. Now, for more than 4 valence electrons, they're going to gain electrons to form negative anions. So anions are a negatively charged ion. Now, if it has more than 4, remember, it's trying to get up to 8 or down to 0. Well, if it has more than 4, it's more than halfway there, so it's going to gain those remaining electrons. And if you're gaining electrons, you're gaining a negative charge. Now, exactly 4 electrons, it can go either way. So exactly 4 valence electrons, most of the time, this is a covalent bond, so we don't really talk about this one that much, but it could happen. Now, 8 valence electrons, there is no change because those are those noble gases. They have a full valence shell. They don't want to give up electrons. They do not want to gain any more. They are happy with that full valence shell of 8. So let's get some practice. Let's look at aluminum. So how many valence electrons does this element have? Well, you can look at the periodic table or you can look at this Bohr model and you can see that it's going to have 3. It is in group 13, so remember, ignore the 1, and you can figure out that it has 3 valence electrons. Now, would it be easier for it to lose all of the valence electrons to get down to 0? So is it going to lose 3 to get down to 0, or is it going to gain 5 to get up to 8? It's going to be easier for it to lose 3 valence electrons because, I mean, it's below 4. So if it loses electrons, will it be positive or negative? It's going to be positive because it's losing that negative charge. In fact, it's losing 3 negative charges, so it's going to be positive. It's losing those 3 negative charges. So this is how it is written. Notice the symbol is Al, and then you write a little 3 plus there to know that it has 3 positive charges. It has 3 more protons than electrons. So let's take a look at oxygen. How many valence electrons does this element have? Well, you can look, it's in group 16, so that means it has 6 valence electrons, or you can look at the Bohr model, and it does have 6 valence electrons. Now, would it be easier for it to lose all 6 of those electrons to get down to 0 or gain just 2 to get up to 8? Well, it's going to be easier for it to gain 2 electrons to get up to 8. Now, if it gains electrons, will it be positive or negative? Well, it's gaining that negative charge. It's gaining 2 negative charges. So it's going to be written as this, O2 negative. Say that, oh, it's an oxygen atom and it's an ion because it has 2 negative charges. It has 2 more electrons than protons. Now let's take a look at neon. So how many valence electrons does this element have? Well, we can look at the Bohr model and count up, and it has 8 valence electrons. But also it is in group 18, so you ignore the 1, and it has 8 valence electrons. Now, would it be easier to lose all the valence electrons to get to 0 or to gain electrons to have 8 valence electrons? Well, it's not going to gain or lose any valence electrons. It's already at 8. It's perfectly content. It has a full valence shell. Now, if it doesn't gain or lose electrons, will it be positive or negative? It's going to be a neutral atom. It is not an ion. How would this ion be written? Well, it's not an ion. It's just a neutral atom, and you just write the symbol, Ne. So at this time, I'll go ahead and give you the verbal code. The verbal code is 152. I say that again, the verbal code is 152. So we did a class activity where you got practice this. You looked at the Bohr model, and you also had to look at an atom that had so many protons, neutrons, electrons. Tell me what element it has, what group number it's in, number of valence electrons, whether it's going to lose or gain or neither those electrons, how many of those electrons, the element symbol, and the ion charge. So a lot of this, but if you understand what we went over, this one should be fairly easy. And not all atoms are going to form ions, and on this sheet, that is it. That's really all the ions that you're going to encounter. Then the next thing that we did was we did the PhET build an atom. So we used this to do similar to what we did, but you were able to build the atom using a simulation, and there's that link that's there. So you could actually build the atoms and make ions using this simulator. So this is the ion video, and once again, there is too much unknown in the universe to take a break from learning. Get out there and question everything.